بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. Hi, my name is Waqas Wajid, and today I'm going to present my master thesis. My first advisor is Professor Dr. Engineer Matthias Peets, and my second advisor is Professor Dr. Engineer Nicole Uri. Before introducing my thesis, I would like to give a brief introduction about myself. I completed my bachelor's in 2010, and afterwards I've done almost 4 years of construction in various construction projects as a civil engineer. So while working on all those projects, I realized the problems which is related to the mega city of the Karachi where I've born, and that sort of intriguing sort of nature brought me over here to Germany to pursue a landscape architect. So I had already some sort of background related to the problems the city is going to face, especially Karachi is facing. So, as the title of my thesis is Spatial and Sensible Planning of Chaotic Metropolitan City through GIS and Remote Sensing. This effect you are seeing, it's actually representing something. I will let you know. So in that master thesis, I'm going to find some solution related to urbanism, allocation of recreational spaces when the urbanization takes place. Reducing amount of recreational spaces have been created. Water management is another issue, and sea intrusion. It's slow but an imminent trend which is facing. So I will from the heading it suggests like chaotic metropolitan city. So for giving that argument a little bit more thing, it's like Carl Jung said, in all chaos there is a cosmos, in all disorder a secret order. So what I'm supporting my argument of, actually the background of my thesis based on a chaos theory, and this theory says dynamical system which is highly sensitive to initial conditions. Small differences in initial conditions such as those due to rounding errors yield widely divergent outcomes for such a dynamical systems, rendering long-term prediction and possibilities in general. Chaotic behavior can be observed in many natural cases such as weather is, and this study can also be used in economical and other philosophical stuff. It's up to you how you are going to find the solution related to it. So butterfly effect, it's an example which we use to support the chaos theory, and this theory, this butterfly effect suggests depicts if a butterfly flaps its wing in Beijing, the turbulence occurred because of that the turbulence of the wings cause turbulence into the atmosphere and will result a hurricane in Texas. So order is half-life. So now comes this is in Germany. It's a famous proverb. They said order is Ordnung ist halb Leben, and which means order is half life. I think other life is the chaos. So we have. I was trying to find something related to that. So I'll just go through with a very brief introduction about the city. Previously. Karachi, like the Pakistan came into being in 1947 when the British left. So at that time, that was a city which partially modernized. But from transition to this present situation it's happened because of so many background from so many different scenarios have been occurred, social and political stuff. So that's how now you can see the present situation. The city is the buildings, the high-rise building with the low resident area. So I think there's no aesthetics. The city is developing without any need. So the first chaos, the main the initial condition which triggered that chaos is, I think, it's population. And from that population, these are the points which I'm going to discuss in this, try to accommodate in my thesis. And then comes the second is the recreational area. When the population is getting increased, the natural, it's not about like the recreational area, so to say, it's going to deplete. So the third issue is mainly the pluvial flooding. It's also an urban phenomena happening in the city, and it also has some reason behind it as well. Sea intrusion is slow but an imminent threat, which faced by this the city itself. So the methodology I'm going to touch over here, it's impact analysis. As you can see from this animation, like when the urbanization taking place, and due to that, this natural land is decreasing, and we are cutting down the natural land, but we try to accommodate some sort of putting green spaces or the recreational area within that. So another methodology would be the spatial planning. Yes, remote sensing space, like you already witnessed from a picture that how the city is developing. So I'll try to find to make some sort of spatial planning. I'm taking the help from the help of remote sensing and the GIS geodesign. So I will going to give you a little story behind that when I was explaining all my different divergent things related to my thesis with Professor Matthias Peach. He listened to me quickly, and after 10-20 minutes, he said, "Okay, what are you doing? It's a geodesign." So I don't want to be get wrong about that method framework, because it's the owner of this framework is Carl Steins, a big shot of Harvard University. So I'm just going to read out how I find it out from the internet. The definition of geodesign is a set and methods to get all stakeholders in different professions involved in order to collaboratively design and realize the optimal solution for spatial challenges in built and natural environments, utilizing all available techniques and data in an integrated process. So this is the process where it's a framework which currently famous nowadays. And now data set. This picture, the red one here, the red and the first two pictures are actually have been downloaded from the NASA's website, and the third one is an aerial image of the city, which are also downloaded from the Google Maps, and from the fourth one is the vector. Are the shape file, which have been exclusively created by me, and it was a really tough job to say. Anyway, so now come to the last one is the OpenStreetMaps. I've downloaded it from the GeoFabric, and the thing which I would like to, the reason to show the slide is it's all the open source data which I've collected. So now, amalgam of international planning strategies for Karachi. I'm going to adopt few strategies which have been already taking place in the world, so I'll try to adopt it while doing this. And so the first one is American Society of Planning Official. It's a whole strategy in 1965. People, the planners of the New York, when they realized that urbanization is taking place, so that's how they come up with the idea to cope with that sort of challenges in 64, if I'm not wrong. So they said 700 acres of, they decided like 12.5% of the total land of the city should have been reserved for the recreational areas. And from that 12.5% land, that's how they categorized 7-8 acres should be reserved, should have been reservations. And one it should include one large city park, 10 neighborhood parks which accommodate, and 50 playgrounds, 100 playgrounds, or 50 playgrounds, and garden and square. Rest are the garden and squares, and that's how they decided the data, and that accumulates around 1,500 acres, and that's how much it is. And if you could round it off, so it would be around more than 15,000, I think 20,000 acre. So that second strategy I used, it's already been embraced by, it's already been adopted by Copenhagen and Copenhagen Cloud-Based Management, and they tried to, in 2011, Copenhagen faced a devastating urban flood, so to say pluvial flooding, and that cost them a humongous loss. So that's after that they came up with that strategy. So Sand Motor Netherlands, this is Sand Engine actually. This is the strategy in Netherlands they have adopted. It's a famous proverb: God created the world, but Dutch created the Netherlands, because all the Netherlands is actually it's on the situated on the coastal line, and they are facing the sea intrusion, and they reclaim the land, and now present day situation is like that. So now coming to the data sets related to the Karachi, and now I'm comparing with comparison between Berlin and Karachi. So the first picture you're looking at, it's the district of Berlin. It also has a story behind it. When I was doing my first year studio with Professor Dr. Nicole Urig, she came. The project was a Yam Beach. It was a place which all the students have to design, and that design, because it was located in Berlin, so she provided us the data related to the municipality and the protocols which we have to follow. And for that protocols, I came to know so many interesting things related to the GIS, related to the GIS, which have all the information which required to develop those sort of plannings have been taken into account. And if anybody wants to design or something, and anybody wants to do something with the data, it's available for all Berlin, or it's mostly on the website, so anybody can look and see what sort of plans it can use. Other than that, you see this data. This data, I took it from the municipality website of Karachi. It's in 2005 when the municipalities, like the town council and stuff like that, got empowered, and at that time they tried to do something, and it have been taking place in 2005, almost more than 10 years ago, and after that nothing happened, so that data haven't been upgraded. And this is, I think, this is for sure, it's a JPEG image. It's just literally like a piece of paper, and with the population data set is inscribed on the bottom of that picture. So from that particular data set, which actually just like an image of like this, but not a digital blueprint, without digital footprint. So from that, now coming up to the first problem, which was the population, how to accommodate in creating this recreation area. So this first data, the picture you are seeing here, it's a data set related to the population, how the population expanded in course of 1947, 51, and 98. These two, 51 and 98, are the census data, official census data. And 2016, that was the projected data because I was working on it. So that was the results were. And now, if you remember that the data which I've created for Karachi, have you seen that the pictures? Now this I've digitized each and every district like that, and it was almost 28 districts, which I've actually digitized from that picture. It was tough job, but somehow I've done it, and I gave the attribute of the data given in the municipality website, and that municipality website, from that particular data I created this sort of data sets, and now comes the dot density district. So now with that particular attribute I predicted another result of the population, the growth of the population, how it would be and how dense the district is, and this is how the attribute table look like. Each polygon, I mean each exactly. Each polygon has been projected on the datum WGS 1984, and it has a spatial location. It's a really important to know about that stuff. So now I've done it for each district to the Karachi, and if you remember, does it make any sense? Implementation of American Society of Planning, I've implemented the whole criteria of how much city has to reserve recreational areas, and so literally saying it's 12.5%, that it accounts if you do it from the area of the Karachi which is there for sure, which cannot be changeable. It's like from according to that 462 square kilometers of the area should have been reserved for that. But what I've done, there is another suggestion related to the American standards, like 1 acre, which equals to 0.25 square kilometers of the area should have been reserved for the 300 people, but I have changed it for the scenario of Karachi, and I've changed it to an acre, 0.25 square kilometer, quarter of kilometer should have been reserved for the 500 people. That's I've exceeded, I've almost doubled that amount, and that suggested the area 127 square kilometers should have been reserved in the 2005 according to the population data, and in 2017 it says almost 200 square kilometers of reservation places should have been reserved for the city, and which accounts for 8 square meter for each person. So, any idea related to this picture? Oh, there's some sort of animation. Satellite came into being. So actually, this is the digital elevation model, which looks like in the raw form like this, and which I've transferred into the raster image, and it's actually the digital elevation model from the satellite. The data I've got it from the website, and now comes the surface heat map of Karachi, and a little story behind this is surface heat map is in 2015 almost some thousands of people have been died due to the heat wave, and heat island effect. Heat wave are just not the things happening because of the global warming, but it's also the way we are developing our cities, and it's creating heat island effect. And from that particular data set, I've tried to OpenStreetMap. It's also open source data, which I've downloaded it. And now, there's 28 districts of the Karachi which I've digitized, so I'm going to implement all that strategy in a one district. And that's how, if you remember about the districts, each projected on datum districts of Karachi. Why it's important? Because each and every district have been projected on the datum, and I've tried to approach the authorities of Pakistan to get to know about the actual projected datum of we are using, but somehow after I haven't unfortunately got any response, an official response to my queries, but somehow there was some students who have already done some work related to these things, so I've downloaded and I took them as a reference, but somehow it's correct. So aerial image of Senegal. So now this is the aerial image of the district, which looks like why I selected that district is because I'm born over there, so I've lived for 25 years in that district. And then comes the land heat map, like how much heat is generating the district, and then come the digital elevation raster model. The most important ingredient for my strategy is street network and population of Senegal. These dots actually represent the population, and this is a vector file of digital elevation model. I have transferred the raster data set to the vector because if you would like to move raster is it's a predictability which can be not that accurate, but somehow the vector results are more accurate and it can be used technically in the drawings as well, so you can get the impression out of it. So what I've done, elevation and street network, I've actually overlaid elevation and street network on the top, and this is important because I've done it due to the result which I was working on, like the things I was thinking of. It's a rain network. It's actually a tool of network analysis. It's a tool in ArcGIS in which I give the variables of the lowest elevation, and the second variable is the street network, and then it's calculated the result, give me the result about the screen area you're seeing. It's actually the best suitable location, and the red is you're seeing is the service area, how many streets it will be going to accommodate, and this is the reason. It's like if you got an elevation of the every street and the area where you're going to build all these sites are the natural depression, so to say, thanks to the Professor Stephen Erwin who gave me the suggestion. And then suitable places, these are the suitable places from the satellite image, you can see that now, and just do not forget they are still following the criteria of American standards, how they are planning, how reserving the areas. And you can see 43 square kilometers, and according to that, it's required, according to 12.5%, which is really ideal situation for a city or a district. It's said 5.4%, 5.4 square kilometer should have been reserved. But according to the population data, which I've taken from that municipal website, it says 8 square kilometers should have been reserved for the for this district, which already exceeded in 2005, and now in 2017 that's accounted for the 12 square kilometer, which we have to reserve for the for the recreational activities. So now you see that these four sites I've created. The first one is it's the major part, and second one is the playground, which has to be 50 different locations, and then comes the 3 neighborhood park district, and the fourth one is an open street map. So the first one I cannot be able to design in as much detail as possible because it's 400 acres. It's a whole project. So just trying to make it, but somehow. So this is how the situation will look like. Now you're seeing that this collects the rainwater from the area, and then it comes to the main city, main park, which I've selected, and now you're watching like this rain happen, and the streets turn it up into ground, and this is another sort of animation how this process will going to work. So this is how it is, and the last point which I would really like to share with this is the causes of sea intrusion. What are the reasons? You know, there is one proverb which is like, don't mess with the mother nature or the mother nature will mess with you, but human beings, as a human being, we are trying to mess as much as we want not to the mother nature. So there is a natural process of precipitation in which this, from this process, the evaporation, and that's how the whole system works. But what we are doing due to urbanization, the main ingredient in the urbanization is the concrete and asphalt, and it's not a natural material, it's a composite, and that composition is making the natural land turning into the asphalt, and it's making it impermeable. Due to that, the natural soil cannot soak the water inside it, which actually really necessary for subsurface aquifers, and because of the asphalt, it cannot be converted, and that's how the alluvial flooding is happening. And other than that, the concrete structure also requires the foundation, also suck up the water somehow, and the last phenomena is the demand of sweet water to use in a daily life is also increasing in this developing city. So that's how they are trying to accommodate their things. And now comes the geodesign. This whole strategy will going to work. That's how the geodesign should have to work. The regional, the town, and the house, and regional conservation, urban parks, and gardens. This is how it's going to work. And then comes the active strategy against the sea intrusion. Sand engine. I've designed that in the coastal area of the Karachi. And then comes sand engine. 5 years after that, it looks like this. The process of succession will take place like that, and the succession is from the starting of the grass to turning into the mangroves is a process. And I'm not a big fan of the reclamation, but somehow just providing a nature to give nature a chance to revive itself. So that's I'm going to suggest, because anyhow they will going to build dikes and dunes because of that. This threat is imminent. So I'm suggesting, instead of using any unnatural material, we could use the natural material, and just in the case, but that's an idea. So now comes to the population is the main issue. It's increasing in all the urbanization areas, so that the urban agglomeration is happening. So to say, the ghettos in particular communities and ethnicities on the basis of religious or linguistic or the culture heritage is developing, and that's also creating the development, and the economy also plays a very powerful role in that development, because the powerful have this things to control that stuff. They can change the laws. It's also impacting the sociological strife in the society, which creating the class segmentation, and then that's generating the intolerance, and from that intolerance people try to find out their political needs on the basis of religion or sometimes ethnical background. And if we try to adopt this sort of strategy, the participation is a main ingredient in which the local people have a say to design all that things related to that. And the education, if you could provide enough education how important the things are related to this geodesign, it will help the district, the local people to do that. And the competition of this design should have been exclusively being given to the university students in a district, and from that district the architects or the engineers or other participants could also suggest their ideas to the competition of the recreational area. Quality is the main fundament on which this strategy is actually based on, and the quality of the roads, especially it has to be very accurate, like a German surveying system from Western Point. You can see it over here all around Germany. It's like how they do their surveys. So, and in GIS there's thing from from which we can do so many stuff related to that, but that's how it will going to accommodate the pluvial flooding and social epidemiology. It's so to say, when we're going to create recreational areas, it will going to help in health activities, because in urban cities mostly people are vitamin D deficient, diabetes and depression and these sort of things is the common phenomena in the health diseases. And then comes the global warming issue can also be addressed because of that, and sea intrusion is somehow be halted for that, and biodiversity, so to say, the natural flora and fauna which have been extincting due to the urbanization could have a chance to revitalize because of that project. That is an engine, and in these recreational areas where we have some sort of trees or sort of greenery, these birds will going to come and try to accommodate it with and try to live with Earth, with us in that scenario. So that's what my whole thesis is about. Thank you so much for your time. Thank you for listening.